All right. We'll be going through the basics of quadratics first, doing some questions. As we do the questions, typically I like to, because I do my class online, um, as we do questions, if you guys could send your answers like into the chat box directly to me when we do a question, that would be great. Just because then you're not sending it to everybody and everyone gets a chance to try and answer some of these questions. All right, so let's get started. Basically, this is our schedule, just so you guys know. I know you guys have probably all seen this in an email, but just to refresh, we're going to be doing advanced math today, tomorrow, and then problem solving on Wednesday. And then on the last day, on Thursday, you guys will be taking like mock versions of the paper test and then reviewing it in class. These are the concepts like according to College Board. So for advanced math, they call them equivalent expressions, nonlinear equations, systems of equations in two variables, nonlinear functions. Kind of vague, not our best like descriptions of these things. But basically it's like, your quadratics, your exponential functions, your other like nonlinear graphs. And today we're mainly going to be doing quadratics. On tomorrow, Tuesday, we will be doing all those other techniques like the advanced math part too. So first things first, can anyone say how we would factor this? I know there's like a way for you to raise your hand on Zoom, so if anyone wants to go ahead, raise your hand. How would we factor something like this? Like, how would we do that? Or how would we like solve for x using Desmos? Okay, Irina.
You would find what two numbers multiply to -10 and add up to 9.
Yeah, exactly. So we're thinking about factors that multiply to give us -10 and then add up to give us +9. Oh my God, there's so many people. Okay. If you're just entering the chat, also just put your first and last name into the chat box. That's how we're going to use it to take attendance. I see some other people in the chat box. They did a very good job answering this question as well. So yeah, we'd have to do x plus 10 and then x minus 1. Those would be our factors. That's how we would factor this. If we had it set equal to 0, then we could solve for x. What about in Desmos? Like if I wanted to know, like, what are my values of x that solve this equation? How would I solve that in Desmos? Since on the test, we're going to have access to that calculator all the time. Can anyone like raise their hand and just quickly explain how we would solve this in Desmos? Okay, I see James in the chat box. Find where the x-intercepts are. So let me share to Google Chrome real quick. So in Desmos, exactly, we would just graph it. We'd be saying y is equal to x squared. Like in this case, we don't even have to factor in order to find the intercepts. We can graph. We graph that, we solve, we know it tells us, once you click on that graph, it would show us that x is equal to 1 or x is equal to -10. And then those would be our answers, like if we were solving for x. So using Desmos, very powerful tool. We'll try to keep going back and forth to see how we can solve things. Okay. Things to remember, these factoring techniques are super important. They come up time and time again on the SAT. Obviously, you don't have to have them memorized, but having them memorized is going to allow you to solve this so much faster. Like as soon as you see something that looks like this, you know to factor it to look like that, and vice versa. If you see something that's like this, you know to multiply it out and it would be something like that. There's another factoring technique of by grouping or using the AC method. I'm sure a lot of you know it. Again, we have the tool Desmos. We can always use that to solve. So, if we don't want to remember this method of factoring, we don't have to. We could always use Desmos in order to solve like for our values of x. But let's just say we had to factor this. Let's say like the question was just asking us, I I don't know, like what is a similar way to write this? And it's a bunch of factored ones. How would we factor this? How would we know how to factor this using that AC method or by grouping? Can anyone like raise their hand and explain this to everyone? Or even if you don't know the whole thing, like, all right, Ali, is that how you pronounce that? You just have to unmute.
Um, so you'd multiply the 6 and the 3, and you'd want it to add it to -7, and then you'd group it by keeping the first and last terms.
Yeah, so we're splitting up that -7 by the factors that multiply to 18, but add up to give us -7. And in that case, what would those factors be?
6x squared minus 9x plus 2x minus 3.
Yep, perfect. 2x minus 3, when we're doing grouping, we just take the first piece, we take the second piece. There's nothing that we can factor out. This is when we're doing like our GCF factoring. Oh yeah, -18. Oops. -18. Thank you, Irina, in the chat box. Yeah, -18. So when we're factoring this, we'd be pulling out 3x. We'd be left with x minus 3. Oh, 2x minus 3. Oh my gosh. 2x minus 3. On the next one, there's nothing that we can pull out. It's just a 1. That's the greatest common factor. So then in this case, between these two terms, our greatest common factor is 2x minus 3 and 2x minus 3. So that's what we're able to pull out. We're left with 3x plus 1. And then we can solve this for x however way we may need. The thing is, yeah, we wouldn't need to know this factoring technique if they're just asking us to find x, right? Because we could plug it in Desmos like we talked about, find the intercepts, most important part. But if there were a bunch of answer choices that were factored in a whole bunch of different ways, it would probably be fastest for us to factor it rather than plug all 4 methods into Desmos and see which graphs overlap each other. I don't know, that's just me, but we can always just plug them all into Desmos and graph them. All right. This is an example of that, I guess. So we want to try and factor this. I don't know if it's really by grouping or the AC method, but we can use some GCF and then do some normal factoring. And when you guys have an answer, put it in the chat box. You can send it to me as a direct message, just so not everyone jumps on your bandwagon with what answer you're choosing. And then as soon as we get some answers for this, we'll review it, keep going, keep it pushing. All right, we're getting some answers. Not everyone yet. Obviously, there's, 28 of us in here? Oh my God. All right, let me just call on someone. Daria, and would you want to explain how you got to your answer? If you're
First I took out the GCF of 3, and then I just got x plus 6 and x plus 1.
all right, so you factored out the 3, you got x squared plus what? 7x plus 6?
Yeah, and then from there I saw which ones multiplied to 6 and add up, so.
Yeah, our factors of 6 and 1. Perfect. That's how we're getting A. A lot of people that responded were also getting A, so that's good. All right, let's keep going. Operations, like with polynomials. So it's technically advanced math. It's obvious. It's not usually the hardest thing, but just adding up your like terms, like making sure like they're, corresponding with either side. So something like this, they're doing operations with polynomials on the left. They say it's going to equal the stuff that we see on the right. How do we figure out what B is? How would we do that? If anyone wants to explain, they can raise their hand, or you can solve for it and put it in the chat. Yes, someone asked, would we simplify the left expression? I would. You may not have to simplify it all the way. You could just focus on the bx term, but All right, so if we wanted to solve, yes, I'm seeing some answers in the chat. Sorry, I'm reading them. So if we wanted to solve this, we'd probably want to simplify the left. We can simplify all of them. You know, we can just go right through. It won't take too long. So 9x squared. The minus is the very important part here. You know, we have to make sure that we change the signs of anything inside. So 9x squared minus 6x squared. Then we also have 5x minus negative 4x. And then we just have like that -1. So that one doesn't have a like term that we can combine with. So we have 9x squared minus 6x squared. We get 3x squared. 5x minus negative 4x. We're going to get plus 9x. And then the -1 is just on its own. So our value of b that a lot of people were getting is going to be b is equal to 9. Does anyone have any questions about this one or why we did what we did? All right, if you have any questions, put them in the chat box. Isolating quantities is another technique that comes up on the test a lot. They'll typically have something like this. Usually they'd explain everything. They'd say, oh, this is the volume of a whatever, like r is the radius, h is the this, like blah, 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 blah. They'll explain everything. If they're just asking us to isolate a quantity by itself, we don't have to, you know, pay attention to anything they're saying. If it's a long paragraph, we don't even have to read it. We're just trying to isolate r. So I'll give you guys all a few minutes. Start putting your answers in the chat box on what you'd get for r if you isolated it. And then we'll talk about this one. All right, I'm seeing some answers. I'll give you guys another like 30 seconds to a minute. All right, so we've got a few answers in here. Again, if I'm pronouncing anyone's name wrong, let me know how to say it when you come on the chat. Is your name Ia or just like IA?
Oh yeah, it's Ia.
Yeah, okay. Awesome. How did you solve this? How did you isolate for R?
So first I divided by pi and h, so I got volume over pi h, and then I noticed that r was squared, so I found the square root of both sides of the equation, which gave me choice D.
Yeah, exactly. So once you take the square root of something squared, they cancel out. I know, obviously we're not doing exponent rules in this PowerPoint. I believe it's tomorrow, but just to get a jump start on that, a square root or a like any root, cube root, fourth root, etc., is just something to the, it's a fractional exponent. So technically, doing that square root is the same thing as doing something to the 1/2. And when we have exponents inside of parentheses, we multiply the exponent. So if you multiply the 2 times the 1/2, you're just getting r to the first. So that's how we're canceling out. Like that's how we're able to reverse something that's squared or something that's a square root by doing that like exponent rules. One other thing, which I know most of you guys are pretty clear on, definitely probably understand the dividing and the multiplying. So if something's being divided by something or multiplied by something, the opposite way to get it like on the other side is to do the reverse operation. So instead of multiplying, you divide, or instead of dividing, you multiply. If there was something added on here, it's kind of like you're doing reverse of like PEMDAS and that kind of stuff. So if it was like plus, I don't know, 5. Okay, I'm still on the eraser. Oops. If it was plus 5, we'd want to subtract everything first and get like whatever we're trying to isolate alone, like without anything being added. So we would have had v minus 5 and then all this other stuff on that side. So we're usually trying to get whatever variable we're trying to isolate like by itself, even if it's attached to stuff via multiplication or division. So we're just trying to follow those orders of operation in order to get something by itself. Solving quadratic equations. This is where it's, you know, starting to get very algebra 2-y. Like this is how we're solving most things. This, you know, we're solving this for the roots, we're solving for x. We can do this a few different ways. So I'll let you guys quickly solve this one. we'll talk about the 3 ways that we could have solved it. All right.
I factored it out, so the sum of A and C is -56, and the factor will be A times -7, which add up to 1. And if you set it equal to 0, it will be -8 and 7.
Yeah, exactly. So we would be getting B. We can solve by factoring, as you said. So we'd have x plus 8, x minus 7. So you'd end up getting B as your answer. Another way, I know, the title of this said factoring and solving for the roots. Since we have access to that Desmos calculator, you could always plug it in, solve for our x-intercepts. What's one other way that we could solve for x if it's a quadratic? I know it's not our favorite way to solve, but what's another way that we could solve to find x? Yeah, someone sent it to me in the chat box. Quadratic formula. A few people are sending in the chat box now. Quadratic formula, yeah. So that's another way that we could solve. Obviously, that way's kind of going out the window now that we have the online calculator that we can solve for the roots. And obviously, factoring is always a good backup method that we have in our back pocket. Quadratic formula mostly is going to be helpful if you see any of your answer choices like having that square root in it. That's our signal to say, okay, quadratic formula. It's right here. This is something they're not going to give you on the test. So if you do not have this memorized, it's one formula that I do encourage memorizing because it has pieces of it that we could use for other things. But before we get into that, I don't want to skip over this slide because this slide is also like pretty important. If they ever ask you for the sum of the solutions, so when they're talking about solutions, roots, x-intercepts, the answer, the values of x, this is all the same thing. So when they're talking about sum of solutions, when it looks like this, ax squared plus bx plus c, we're able to solve for the sum just by plugging in -b over a. We're able to solve for the product just by plugging in c over a. So this is a quick little shortcut. We don't have to solve for x in order to figure out what the sum is or what the product is. And it's a foolproof way of like getting to that answer. Quadratic formula, which we were talking about. Definitely something to memorize if we don't have it memorized. Let me just do some highlighting, not with the yellow. So this piece right here, -b over 2a. Do we know what we could use this for when we're like talking about quadratics? Like, what does this find us? All right, someone sent it to me via direct message. Axis of symmetry. Yes. So this is finding axis of symmetry for us, which also then in turn finds us, is also going to find us the x coordinate of the vertex. So if we ever quickly needed to find x coordinate of the vertex without like plugging it into Desmos or like very quickly looking at it and saying, okay, what's the x coordinate of the vertex? I just need to know that. We can find that by using the axis of symmetry for our parabola. So that's like that, region. On our next slide, we're about to check out why this is so important. The underneath of the radical is pretty important for us to have memorized. The test loves to ask questions about this. So it's called the discriminant. We don't need to know that it's called the discriminant. If you want to have that memorized, totally cool with me, but you don't have to have it memorized. The discriminant b squared minus 4ac, this is what's telling us the number of solutions. So if it's less than 0, there's no solution. Or, for everyone who learned about imaginary numbers and all that kind of stuff in their math class, there's, 2 imaginary solutions, like non-real solutions. But for the case of the SAT, no solution. If it's equal to 0, there is 1 solution. And if it is greater than 0, there are going to be 2 unique solutions. This is just something to keep in mind. They love to do questions like this where they have variables for like A or B or C, and they'll ask what variable for A would make this have 1 solution, and then you have to solve and figure it out. And if it's something that doesn't have a bunch of answer choices for us, it's not that easy to figure out. Yeah, so let's just try this last one, and then we're gonna jump into a bunch of questions, I believe 5 or 6, I think. But we'll try this one first. I'll let you guys try and solve for A. It's using that technique that I just showed on the last slide, so maybe I'll try and, if I can move this on the side. Yep, perfect. So we're solving for A to have exactly one real solution. All right, so we have some answers. Afzel, could you explain how you got to your answer for this one?
Yeah, so I used the formula, D equals B squared minus 4AC. I plugged in 8 for B and 1 for C. And I got 64 minus 4A equals 0. Subtracted 64 on both sides. I got A equals 16.
Yeah, quick, definitive way of getting us to our answer. Let's just say, you know, all of a sudden we're taking the test and we don't remember this formula. You know, we're sitting here, we're looking at this question, we're like, like what do they mean? How am I gonna find A? When they're saying one real solution, what does that mean in terms of a quadratic? Like if I had to solve this by like looking at it on Desmos, so let me pull that up. So when we type this in Desmos, whenever you put an extra variable that isn't X or Y, as long as you have an X and a Y variable, it asks you, it asks you to add a slider. So I did that. Yeah, someone just sent me in the chat box. They say there's only 1 0. So only 1 0 means it's only touching the X-intercept one time. So, you know, if I was looking at this, oh my God, I probably want to zoom it out a little bit so I can see the whole thing. Let's just see, like, if A is 1, okay, I'd have 2 answers. So I know I need that whole graph to shift up, right, in some way. So let's just, you know, scroll down. Oh, that flipped it upside down. That's not really helping us. So let's see. We're flipping it back up. It's moving up. It's moving up. It's moving up. It's moving up. Okay, well, it still has 2 solutions. So the slider isn't always great because it's, yes, we are allowed to use your own calculator. You're allowed to bring your own calculator, which honestly I'd recommend because I'd much rather do some simple calculations in my own calculator. I don't love graphing on the graphing calculators. That's why this tool is really helpful on the actual SAT. But again, so they only plug it in to be from -10 to 10. So now I know it needs to go a little bit higher. So let me go up to 20. Let's just keep, and let me also, oh no. Let me also make the step 1 just so it's even. I know like maybe it'll be a half or a fourth or whatever, but like I'll figure that out later. So let me just move it up. 15, still not enough. 16. Perfect. It has 1 0. So I know the value of A equals 16 would give me one solution. My only issue with this is obviously it's good. Yes, once it's past 16, it's none because it'll go above. Great question, Justin. My only issue with this is it's not as surefire as plugging it into that formula. So if we can have that formula memorized, it's great to use. Like we definitively solved, we found out it was 16, that's the answer, we're good. With this, it's like, you know, you have to drag it all over the place, try and figure it out, like whatever. This is good, in my opinion, if the question was multiple choice. Because if the question was multiple choice, then, you know, we would just sit here and be like, okay, A is 4. All right, that doesn't work. A is 10. That doesn't work. A is 16. Oh, that works. Okay, perfect. That's my answer. So if it was multiple choice, I think this method is great. If it's not, it's just a little bit too much. Like, you know, you're moving it all over the place. It takes a while. Steven, I know you just entered. Can you just type your first and last name in the chat box? It's just for attendance purposes. Yeah, so that's why like this method I think is good if it was a multiple choice question rather than, you know, free response. let's share back. So we've got some questions to go through. Any like general questions as of right now? I'm just gonna start showing one of the practice problems while if anybody has any questions, they can always shout them out to me, put them in the chat box, but I'll let you guys start working on this one. How do you know how many roots an equation has? Oh, yes, Steven. So it's the formula which was on the previous slide, but it's b squared minus 4ac. If it's less than 0, there's no solution, so there's no roots. If equal to 0, there's one solution or one root. If it's greater than 0, it's two solutions. And then for these questions, we just want to send them as direct message for the answers, just so we're not, convincing anyone that our answer is right. If the degree is 3 or 4, Stephen, they would have to show us a graph. So they'd have to show us like a graph, and it would be, like going through something like that, through the x-axis. And then we'd just be able to tell how many roots there are by how many times it touches the x-axis. With questions like that, it would be a little bit hard, but they could also do something like this and like have you like write out the actual factors of it as well. All right, I'm seeing a lot of answers. Everyone's getting the same thing for this one so far. I'll give you guys another like 30 seconds. All right. All right. Jocelyn, do you want to explain like how you got to your answer?
I just subtracted 14j from both sides, and then I divided both sides by 5.
Yep, exactly. Pretty straightforward for isolating k. This one's not too bad, there's no squares, there's no square roots, nothing like that. So we're just following order of operations in order to get this answer. So that would have been what, A? Perfect. Let's keep going. Next question. They're giving us something like this. They want to know what's the sum of the solutions. You can solve this again in any way you want. You can use Desmos, you cannot use Desmos, whatever's fastest for you, I'm cool with. We'll give you guys a few minutes and then we'll go through it. All right, so I'm seeing some answers. I'm assuming people are kind of confused. Does anyone want to like explain like what they're trying to do or what they think they should do to find out what the sum of the solutions is for this? Yeah.
I hope I'm remembering correctly, but for sum of solutions, it was negative b divided by a.
Yeah.
So I went ahead and I just simplified the equation and found my b and a values so I could do that expression. So I got x squared plus x minus 56 equals 4x squared minus 28x. And then I combined like terms. I got negative 3x squared minus 27x minus 56. So my b value was oh, sorry.
No, you're good. When you move the 28x onto the other side, did you add it or did you subtract it?
Oh, I think I oh, so should it be 29x?
Yep.
Okay, my bad.
No, yeah,
So
you're good.
positive 29. So then it'd be okay, I see. So negative 29 divided by negative 3.
Yeah, so we'd have negative 29 divided by negative 3. We just have 29 over 3. If you plugged it into Desmos, we'll talk about that. To answer questions in the chat box, sum of solutions, it just means you know, for example, if you solve for this, if you factored it and you found, okay, x is equal to blah, 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 and then x is equal to whatever the other value of x is, and we added them together. It's just like adding up the solution. But the reason why they ask what is the sum of the solutions or what is the product of the solutions, like things like that, is because, you know, we have these little formulas that we could do it a lot faster if we know them. Like if I know this formula, I can do this problem so much faster, right? Than actually factoring this, finding the x values, adding them together. Again, yeah, you can keep it as 29/3. So if it's open response, you can, I keep going to say grid as if we're gonna have a paper test anymore, but we don't. So you can write it in as a fraction, or most likely, like if it was a decimal, you're putting it to, I think you could put it to like 2 places or something like that. They'll usually specify if it's a decimal, and I think they say it. There's a whole rule sheet on the front of the test, and it says, okay, if you round this to a decimal, you have to put it to blah 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 places. Like it says that. Let's just say we didn't remember that sum is negative b over a, right? If we wanted to find the sum of the solutions, we also could have plugged this into Desmos. So I went ahead and did that. And you know, the great thing about Desmos is we don't have to have it be y equals blah, blah, blah. We don't even have to, like, you know, write all this out, multiply it out like we would if we had to put it into our actual graphing calculators. So then we see that the solutions would have been 2.6, 6, 7, and 7. So I know those aren't our best numbers, like 2.667 plus 7 would have given us this. We could also put it as a fraction. That's not really the fraction I would have wanted, right? But it's supposed to be, you know, because it's repeated, right? So it's like a third. You'd have to probably convert this as a mixed number yourself, which is where it would get a little bit complicated. Yeah, Desmos pops up on the test. Like it, let me share back to my iPad so I can like draw this. Basically on the test, I'll use this right here. So on the test, like this will be the Desmos calculator, and then it'll ask you the question over here. So you'll always have access. I think you can, like, you know, minimize the screen, but you'll always have access to Desmos the whole test. You can use a calculator the whole time now. Justin, good question about the rounding. I have to reread they have rules, right? Like at the beginning of each section, they give you like rules. So I'm assuming they would say that. I'm gonna look it up while you guys work on this one, like on this question. So you guys work on this. I'm gonna Google that for you about the rounding. All right, so we're getting some answers for this. I'll give you guys another like minute or so and we'll review it. Also, Justin, to answer your question, it says on like the paper version of the digital SAT, it says that your answer can be up to 5 characters for a positive answer and 6 characters for a negative answer. So if it's a decimal that repeats, they're saying to truncate it or round it at the 4th digit. So you could either just like drop it and say, okay, it ends in this, or you could round it up or down. You can write an improper fraction, but you cannot write a mixed number. So you couldn't write 3 and 1/2. You'd have to put it as 3.5. All right, so we're getting some answers for this. Afzal, do you want to explain like how you got your answer?
Sure. So I use a quadratic formula for this one.
Mm-hmm.
So I plugged in my values and I got 2 plus or minus radical -2 squared minus 4 parentheses 1 parentheses -9.
Yep.
Yep, so I got 2 plus or minus radical 40 over 2, and I simplified it down to 1 plus or minus radical 10.
1 plus or minus. Yeah, because that'll be what, 436 plus 4 is root 40. Yeah, so that would be, just for the purposes of this, we're able to simplify the 2 over 2 as 1. On the inside, we're getting 4 plus 36, so we're getting 40. As you said, we could simplify that. So it's technically 4 times 10. So we could bring out the 4 as a 2, leave the 10 inside, the 2's cancel out. Yeah, our radical k would be 10, which is B. So the 40 can be simplified, and it should be simplified only because, they're not saying the root k was over anything in that answer. Oh my God, I have a bunch of questions. Okay. Let me look at them really quick. Oh, well, this one's a duplicate, so that's great. This has to do with the number of solutions, so I'm going to skip that one for now because we've practiced some of those. Let's start with this one, and then we'll go back and we'll do that other one last. So this one has to do with like factoring techniques. Some people are struggling with this one, so I'll start explaining it. It's weird. It's definitely weird. So like if you're not getting this one, it's totally fine. Okay, so for this, it's hard to see it at first. They're telling us u squared minus ut is 6, and then t squared minus ut is equal to -2. Kind of weird, right? Then they're saying, what's the value of 2 times u minus t squared? So let's just see, like, what if we put u squared minus ut plus t squared minus ut all together? I'm only thinking that because I'm thinking of this, the u minus t squared. If I multiplied that out, u minus t squared, I'm getting u squared minus 2ut plus t squared. We do not, under any circumstances, it's really bad math if we just took that squared and put it on u and then put it on t and we didn't FOIL it. We had to FOIL that. It had to multiply out. We would get this, u squared minus 2ut plus t squared. Anyway, moving from that, so we know that's what this would be, right? If we multiplied it out, we'd get this. So the top part, if we combined it, we're getting the same thing. We're getting, oh, that's a highlighter. We're getting u squared minus 2ut plus t squared. Same thing. So when we did this, it was really like doing 6 plus -2, which is 4. So then we'd have 2 times 4 is equal to 8. Like that's how we're getting that answer. I know this one is confusing, but it all just has to do with those factoring rules, those ones that I was showing before. The what is this one? The difference of like, not the difference of 2 squares, but yes, Ia, you want to ask a quick question about this one?
Yeah, I just want to know if my thinking process was correct. Like the first thing that I noticed was when it was asking for u minus t, I noticed that that's what you would have gotten if you took a u out of the first one. So I kind of got an answer mixed with the letter as well, but now that I look at this, that makes sense too.
Yeah, let's see, because you could have pulled out u and you would have gotten u minus t and it would have been 6. The only thing here would have been we wouldn't have known like what's what, right? Like we wouldn't have known that.
I got like 6 over u times 2 squared. Like I think that wouldn't give us like a number answer.
Yeah, we'd have to do a lot of guessing. I think we'd end up like guessing like what the factors were. You'd probably be like, oh, maybe this is 2 and this is 3 or something like that. Like we don't know. And then if we did get 2, then it would be 2 squared, which is 4. Like that would work, but like that would have been a lot of guessing. So using this technique, like with this factoring, is like the, I guess, most like math efficient way of like getting to an answer. And then we only have a minute left. I'm gonna try and take a look at this one with you guys tomorrow, like when we do the more advanced math from 4 to 5, just because this one is kind of confusing and definitely something that could come up on the test. I feel like they're doing a lot more with graph translations. I've noticed like in their practice test, they've had a lot more with graphing and graph translation. So I want to go over this one tomorrow for sure. Again, if you want any of these PowerPoints shared with you, just send me an email, like to my email that I sent, only because, you know, I might get lost in all of these like comments on the SAT bootcamp, like in the comments here. So if you send me an email, I'll definitely like share all these PowerPoints with you guys. If anybody has any additional questions, you can stick around. I'll stay on for about like 5-10 minutes to answer any questions you guys have. I know there is an English session that's going on right now. So if you're gonna go hop on that call.
It's just,
yeah.
It's the same call, Molly.
Oh, I have to leave.
Yeah, unfortunately.
I have to go.
Because it was easiest that there was one link for everyone, so we're all on
That
the
makes
same.
sense.
But if you stop your recording and then I'll start a separate one, so it's easy for you to cut.
Yeah. Okay, let me just unshare that. Yeah, you guys can just shoot me any emails with any questions you had about any of that. Let me stop. Where's the recording?